So we've got this huge clash happening right now. On one hand, AI is exploding, getting smarter and more powerful by the day. But on the other, the energy to fuel all that power is getting crazy expensive. It's a real problem, right? Well, today we're going to look at a pretty wild solution that doesn't just fix this, it actually turns it into a source of profit.
All right, let's break this down. It's a really strange situation. The actual chips, the brains behind AI, they're getting cheaper and way more powerful all the time. But the juice to run them, the electricity, that's getting more and more expensive. And that gap right there, well, that's not just a problem, it's a huge opportunity. The game is changing. It's not about who has the fastest computer anymore. It's about who can get the most value out of every single drop of electricity.
And a big piece of that puzzle comes from tackling this one, just enormous source of waste. Think about a typical data center. You'd assume all that power is going into computation, right? Nope. Almost half of it, 40 to 50%, is just for cooling, just running giant air conditioners to fight the heat those computers pump out. All that energy just, poof, vented into the air as waste. It's kind of crazy when you think about it. So what if we just stopped fighting the heat? What if we started using it instead? And that brings us to this really elegant idea. A new kind of machine that's not just a computer, it's also a heater. And this is really the core of the whole DePIN model. DePIN, by the way, stands for Decentralized Physical Infrastructure. Basically, a network of real-world things all working together. And the heart of this network is what the source calls a compute boiler. I love that term. It's not just a server anymore. It's a device with two jobs. You put one thing in, electricity, and you get two valuable things out, powerful computing and usable heat. Absolutely nothing gets wasted. And how it works is actually surprisingly simple. So you've got electricity coming in, powering up these high-end GPUs as they crunch through heavy AI jobs. But instead of noisy fans blowing air, a liquid cooling system runs right over the chips, soaking up all that waste heat. That liquid gets super hot, and then it's piped out, ready to be used for something else. It's this beautiful, closed-loop system that turns a major problem into a valuable product.
And we're not talking about just warm water here. This stuff comes out at 60 to 65 degrees Celsius. That's really hot. Hot enough to heat entire buildings, keep a greenhouse going all winter, or even heat up a swimming pool. It can also be used in factories for industrial stuff. The point is, this isn't just some byproduct. It's a valuable commodity that people are already paying good money for.
Okay, so when you have this dual output system, it completely flips the old data center business model on its head. The source material calls this the energy double-wheel drive model, and it's all about turning your biggest costs into your biggest profits.
See, a DePIN node isn't just a one-trick pony. It doesn't rely on a single income stream. Instead, it's got four of them, all running at the same time. You've got money coming in from the computing power you're selling. Then you've got revenue from selling the heat. You can even make money from providing local data services, and on top of all that, you get token incentives just for being part of the network.
And the bottom line here, well, it's pretty staggering. Look at this. For every 120 euros you spend on electricity in a traditional data center, that's it. It's a 120 euro cost. But with a DePIN node, that same 120 euros in electricity can generate 190 euros in revenue when you combine the compute and the heat sales. So suddenly, that 120 euro bill becomes a 70 euro profit. It's a total game changer. You're not just trimming expenses, you're turning your biggest cost into your number one asset. This whole new economic model basically creates a new kind of treasure map for the entire world. But the treasure isn't gold or oil. The sweet spot is finding a place with three things: cheap power, cold weather where people need heat, and a government that's on board. It's kicking off a whole new kind of gold rush, but for megawatts, especially in colder parts of the world.
Okay, let's look at a few hotspots. First up, Canada. It's got this amazing 1-2 punch. For starters, it has some of the cheapest, cleanest hydropower on the planet, especially in places like Quebec. Then, you've got this government program that gives you up to 35% of your R&D and hardware costs back in cash. That just massively speeds up how quickly you can get profitable.
Then there's a place like Norway, which has a totally unique advantage. The government there has policies that pretty much require businesses to capture and use their waste heat. So what does that mean for you? It means you have a built-in, guaranteed customer for all the heat your DePIN node produces. You're not just selling a product, you're plugging directly into the country's national energy plan. And over in France, it's all about maximizing your value. On one side, the government has this heat fund that can subsidize up to half the cost of your project. But on the other side, you're right next door to a huge market of AI companies. Being close means you can offer super fast, low latency computing and charge a premium for it. So you're getting a discount on the setup and charging top dollar for the service. It's the best of both worlds.
Yeah, and this is the actual government agency that's making it all possible. They're actively putting money into these kinds of projects, helping turn what used to be industrial waste into a real national resource. Okay, so let's zoom out for a second. We've been talking about individual machines, these compute boilers, but the grand vision here is so much bigger. We're not just talking about building better data centers. We're talking about building a whole new kind of infrastructure for our cities, a true energy internet.
And the roadmap for this energy internet looks like it'll happen in about 3 stages. Right now, we're in the startup phase. It's being pushed forward by the early adopters and those government incentives we just talked about. But next comes the expansion phase. As energy costs keep climbing and companies have to start reporting their environmental impact, this tech goes from being nice to have to need to have. And finally, you hit the mature phase, where these nodes could become standardized financial assets. You'll hear the term real-world assets, or RWAs, that you could invest in just like stocks.
And this all leads to a really mind-bending final vision. Stop thinking about data centers over here and power plants over there. Imagine a future where every single building, every factory, maybe even every power outlet is a potential part of one massive citywide computer. In that future, to use the quote from the source, the city itself is a giant DePIN node.
You know, this completely changes how we think about energy and data. It's a world where computing power produces energy and energy produces capital. So I'll leave you with this question to think about. If your biggest monthly bill suddenly became your biggest monthly paycheck, what else in your world becomes possible?